Okay, I just noticed I missed slide 21, another example. So this is just another example how to do redox stoich. Okay, so in this case, we have acidified solution of potassium permanganate. It's used to titrate 10 milliliters of 0.05 moles per liter solution of tin 2 chloride after 3 trials, an average of 16.8 milliliters of potassium permanganate. Titrant was used to completely titrate the sample. Calculate the molar concentration of potassium permanganate solution using the following evidence. So again, we start by writing down all of our entities that are present in our solution. So we have potassium, okay, that's part of the potassium permanganate. Okay, we have permanganate, oh, and it says acidic here, so we're going to write down the H+. We have MnO4. We have tin 2. Okay, tin 2 chloride, so we have chloride. And we have water because they're aqueous, okay, which means that it's water spread. Okay, now we look on our table of half reactions, okay, and write down kind of our so here's our table of half reactions. Again, write down our oxidizing reducing agents. So again, our strongest one is going to be our permanganate, and then tin 2 is I think our strongest reducing agent. We would just want to write down to start with which ones are oxidizing agents, which ones are reducing agents. Yeah, this one can be both. Okay, chloride is a reducing agent. And actually chloride and water can also be a reducing agent when they're together. Okay, now we're looking for our strongest one. So our strongest oxidizing agent is our potassium permanganate. Write down its half reaction. Again, exactly we see it in the book. Exactly what we see it. And then we have our tin 2 is our strongest reducing agent. Okay, so we write its oxidation half reaction. So we have tin 2 plus. And then it's producing tin 4 plus and 2 electrons. So it's actually the exact same reaction as we did in the example in the other video. And so I'm going to write it down its total reaction. Okay, so here's our balanced reaction. Again, something I forgot in our last video in the example is we should always say whether it's spontaneous or not. And so yeah, in this case, we have a strong oxidizing agent. Okay, that's up here, and our reducing agent's down here. So as long as the oxidizing agent's above the reducing agent, this is spontaneous. That's as much as we need is just write spontaneous above it. Okay, now we want to write down what we're given. Okay, so we're given our volume, okay, 10 milliliters of our tin 2 solution. So we have, I'm going to convert it to liters. Okay, and then we're looking for, we're given this concentration is 0.0500 moles per liter. This is the concentration we're looking for. We don't have it. And we're given the volume. Again, we're looking here. This one is dark pink. So I can cancel it out because the rest are light pink. And we have our 16.9, 16.7, 16.8. So again, 16.8 is going to be our average. It's kind of that middle number, 16.8 milliliters. We're going to convert that so it gets 0.0168 liters. Again, for this one, again, using unit analysis, we start, this is our given, this is our desired or required, whatever you want to say. So we start with our volume, 0.01 liters times 0.05 moles per liter. Our liters cancel, times it by our desired over given. So in this case, we have 2 moles or 5 moles. Moles cancel, And then we want to end up with moles over liters. So we're going to put liters on the bottom, 0.0168. So again, if you had left this in milliliters and milliliters, they would have canceled out. Oops. Sorry. So yeah, if we would have left in milliliters and milliliters, they would have canceled out. Either way, we should get our answer of 0.0119 moles per liter. Okay, and I'll show you the other way. So to solve for it the other way, again, you just start C equals N over V, rearrange it, N equals C times V. We got 0.5 times 0.1, same thing as our start. Now we write down how many moles, times that by desired over given, get the moles of desired. Now we have that, C equals N over V, so moles over volume, and we end up with the same answer at the end.